Hello and welcome to this introduction quick start video tutorial for Effex 2.7. What we will be covering here are the very basics on how to work with Effex and quickly get some results. So we won't go into too much detail, but let's take a look at the interface. First of all, we have all the stuff that belongs to Effex in the Navier menu up here. We have all the tools and nodes that we can create in order to work with our Effex framework. In the support section down here, we can access the documentation, online services, which are also pretty important because it allows you to do online updates, manage your license data, update a serial number, for example, and other stuff. Anyway, let's start by creating an Effex toolbar. As you can see, I have it already in my interface, so you want to put it wherever you want or wherever it fits your workflow needs. But it helps us working faster with Effex now. And Effex is divided into two kind of object types that you can create. First of all, there are NodeGroups that we find here, or in our toolbar, we find them here. It's just the same. And we have the low-level nodes. These, which are actually doing all the work. And we can also find them in this section from here to here. All right, so let's just know that there are NodeGroup presets and that there are low-level nodes. And if I create a low-level node, let's just create a particle group, for example. And I can create other nodes like a grid channel or a mesh, and whatever I create to, well, set up a simulation. I can take all these, create a node group. So let's assume this setup would do anything useful. And then I can drop all these nodes in a node group and they will disappear. So this node group, as the name suggests already, is grouping all these nodes into a single node. And it provides us with a single interface holding all the settings. Well, that's actually all I would like to say about node groups and low-level nodes. So let's keep it like this so we know node groups are very useful. But let's just create a setup now. Let's create a liquid simulation. Whatever setup you create, we need an Effex scene. That's the very first thing. And in this Effex scene, we have global settings that define simulation quality, simulation performance, and simulation resolution, for example. Leave it as it is in its default state. And now we go into the node group presets and we go into the single section. This is new in 2.7, and here we have 6, well, node group presets, and they all do or provide us with a certain setup. And we can find down here the liquid setup, which is for a flip simulation. Let's create this. What we get are two objects, the liquid flip object and a particle force gravity. Well, you can already think what the gravity force is doing. It is emitting gravity to the particles that will be created. And the liquid flip object, or node as we call it in Effex, provides us now with settings, well, to initiate a liquid simulation. But first of all, what we need to do is drop it into the Effex scene as a child. That's the most important thing. If I put it out again, well, it's disabled and does not contribute to the simulation anymore. And we can already see that something changes here as well. This is the pipeline viewer. If you think of a simulation, well, you may have heard before that there are certain simulation stages, you know, like first of all, particles are emitted. Then the next stage would be particles would be transported according to a certain force that is acting on these particles. In the pipeline viewer, all these stages are presented to you or displayed. And let's put back the liquid flip into the effect scene, and we can see something changes here now. And we can see different stages: the volume stage, an emitter stage, advection, so transport stage, etc. And now we can also see that there are certain operations happening in the pipeline. The first thing that happens is called static obstacles of the flip particle. Then there is another stage that follows, static volumes, and then we have particles being emitted, then boundaries are handled, then the transport is coming, just as I explained before. So you see, we can see all the individual stages that happen inside of this liquid flip node group preset. You may want to put your pipeline viewer into the interface as well as I did. Okay, enough talking. Now let's just take a look at the settings. And the first thing that we notice is there's an emission mesh that we can specify. So we could simply drop it here. Now let's move this up. We can already see a change there. Make it invisible. We can see that there are blue particles in this box now, in this dynamic simulation space now. And these are the liquid particles actually. So this is a liquid body made out of particles. I just rescaled this cube. So all the particles are generated inside of this cube now. So inside of the volume of the cube. That's why volumes are generated here. Aha, okay, that makes sense. Just play it and we can see that it is directly moving as if it was a liquid. So we can now start tweaking our setup to create a more, well, convincing simulation, for example. And we'll be just playing around and talk about what I'm doing alongside. But first of all, we can just try what this gravity node is doing. It is a PF gravity, so this means particle force gravity. This force actually acts on particles, and it is assigned also here in the forces list. And if I turn it off, you will see that the particles are not moving anymore because there's no force now acting on them. It is a zero gravity situation. By default, the particles that are generated are not moving. We need the forces to, well, let them react to them. So that's why gravity force, well, most of the time you want the gravity force in a liquid simulation setup. That's why we turn it on and gravity is acting on, well, the particles now. And I can set a different intensity, you know, so they will be falling faster or of course slower as well. All right, and we can now add more forces. For example, we can generate another acceleration force because that gravity force is actually an acceleration force. I just renamed it PF gravity. So with that force, we can just add a constant force to our particles. By default it is the gravity force by default. So let's just change that to a positive direction. And now we want it to act along the x-axis. Before it was along the y-axis. As it is assigned already, we can see now that the force is actually acting on the particles and pushing them constantly along the x-axis. Well, maybe I don't want that. Maybe I just want the acceleration along the x-axis to only happen at the source, you know, where they are emitted. So, how can I achieve that? And now we come to another, well, very important node type, which is constraints. So let's go into that force and change tab constraints. And this is like MoGraph modifiers, for example. Constraints are very much alike. And also here we have this C button that I have used before here to add the acceleration force. I just haven't told you anything about it, which I'm doing now. So again, in the constraints tab, you can see all the link fields, which are actually ports, have this C button, which is called a candidate button. And maybe you can now already guess what it does. If I click on it, it gives me a list of candidates that fit exactly into this field. If I go here, it gives me a list of all the nodes that fit into this field now, and which I can now create newly. So let's do this, because I remember I wanted it to be exactly only where the emitter is. I knew already that there is a volume because the particles are generated inside of the cube's volume. And I have a constraint CS volume down here. Well, that's fitting, I think. So I click on it and it generates this constraint volume. And here I can now specify a volume. Again, we have this C button. So now I click on it. And now we can see a list. We have 4 objects here. And although we cannot see them here in the scene, we can see them in the pipeline viewer. Flip particles emission mesh. I find it here. We have flip particle static obstacles also here. Static obstacles volumes, emission volume, there we go. So I know that these volumes of all these objects are now actually inside of this liquid flip NodeGroup preset. So I can just make myself aware that this is the case. I don't have to worry about it too much. And as it requires a volume, well, let's take a volume. And it is the emission volume because I know my particles are generated inside of the cube, which is the emission volume. There you go. So now I have specified that this constraint will only return anything to the acceleration force if it is inside of the volume. So let's play the simulation. And now we can see that the water is pushed along the x-axis, but otherwise, if it is outside of the emission volume, it is not affected by that acceleration force anymore. So we constrained the space with our volume constraint to this cube's volume. That's it. And that's how you work with constraints, for example, all the time. Make an example of this, and we can add another constraint to this acceleration force. Because for now, it is just moving constantly in static to the right side and splashing down in the domain container. And maybe I've already noticed that all the simulation only takes place inside of this simulation box. Anyway, let's just create just a new constraint, and this time I take the constraint noise because I would like the motion to be, well, randomized a little more. So I go in here, let's do it like this, and well, more contrast. So white values would be yes, keep on emitting the full value, and the black color would mean no acceleration force at this certain point or for this particle. Well, let's do this. As you can see now, it's not hitting the wall anymore that straight. There we go. And maybe I would like to see how the force is actually acting on the particles. So let's go into the liquid flip again, into the display option, flip particles, and here we have a threshold value. Let's just put this down to 10, for example. Now play the simulation. You can see now that if a particle has a velocity greater than 10 units or voxel sizes, in that case, then it will be displayed as white. Otherwise it will just have the blue color, or I could of course change that, have a different blue color or whatever color you want. Anyway, so let's just play with this so you can see the effect. It's just the max of the range, of the velocity range possible. But it, well, tells me much better how the forces are reacting to these particles. So let's just play a little more with this one. Just going down again, or maybe let's just try something big like this. Ah, that's much better. Right. Well, let's take 1,500. Not yet there. You know, I'm just tweaking and playing around with this. And you should also do that to get your specific look. Maybe add some animation speed. There you go. This looks much different now. Splashes different, really. And I can just keep on tweaking this, or choose, of course, a different type, you know, like this one. Maybe increase the force as well. Anyway, I guess you get the point. So now let's take a look at some more settings of the liquid flip NodeGroup preset. Parameters. Alright, so we can now also, and I get a little quicker now because I've talked too much already. Let's just generate something. Imagine, of course, you probably have another object. Let's just create a cube, another. Here it is, putting it down here. Maybe rotating it. All right. And that's it. You know, and now it reacts like, well, a static obstacle. Next thing I would like to do is, because I would like more water to be emitted longer. For now it is emitting, we go into the emission tab of the liquid flip, into the duration settings, and the emission is half a second long now. So let's just maybe make the simulation longer. Set this to 2. Now it will be emitting 2 seconds long, like this. There you go. I can also give them a normal speed. And of course, all the pressure forces are still reacting, all the liquid forces, so they're not simply exploding to the outside, but due to pressure forces of the liquid, we kind of have, well, this situation. If I wanted them to, well, expand to the outside more, I could set start distance inside volume to 25. We can see now that only the areas at or near the surface of the cube, of the emission cube, are generating particles. Let's see the effect if I increase this. So more and more of the inner volume will be filled with particles. If I set this to 0, no particles at all. Just some percent, only the very ones that are very near to the surface, etc. I can also do this on the outside, so extending outside of the cube actually. Anyway, in that case, let's just put it back to 20, and now the normal speed will have them emit to the outside much more, because in the inside there is no particles, no liquid which the other liquid particles on the surface can interact with and have pressure differences, etc. So if you want in a liquid simulation setup to have the emitter splash the particles to the outside, just have the inside of whatever volume you use not contain any particles, using the start distance inside volume, for example. Anyway, so let's reduce this. This is too much for my taste. Yeah, like this. And we can add more jittering, so randomizing the normal speed. And this gets a lot more interesting already. But remember, we have a low gravity set. Let's just put it back to our Earth's gravity. Of course, at any time, you can, well, move your emission cube volume like this and have it splash even more or more interestingly, right? Okay, so back into the settings. Some more I would like to show you. Of course, you can directly control the emission. Let's put this back to 100%, for example. And the emission also here with constraints. We can already choose, well, the noise one, for example. And here we go. It is directly applied. And of course, this also can give very interesting splashing and liquid body simulations by directly modifying the emission itself. Also worth now to go here into the particle settings. We can set behavioral things and performance things. For example, if we want to take substeps when they are transported, the quality of the transport, if we have collision detection with other volumes at all. Also a render size. So this is a very simple one using instance spheres, but I can set, let's say 1 centimeter, and if I, come on, turn this off, and we can see that they are added for rendering. This. So this helps you quickly set up a rendering or test renderings, or sometimes it's even enough to take these, you know. Put a material here on the liquid flip actually. Take the cube out, not necessarily in there. Give it a color. In that case, I'm using luminance, like this. Oh, we got it on there already. And we will have it on the render spheres. So we also have, of course, some settings to change the simulation domain, which is also very important because we don't always need this shape, so we can change it. Increase the simulation space, of course. Be aware that changing this dimensions or the space will increase the memory consumption, and of course it will take longer to simulate because more space has to be simulated. And we can also, well, open up container walls. For example, the left side here I have opened up. So let's just run this again, and we will see that once the particles reach this spot on the left side now, that they will be, well, dying off, they will be killed. You can see that here now, all the particles magically disappear because they get outside, because they get outside of the box, of simulation box, and they die. But why are doing that? Because here in the particles tab, we have set kill outside dynamics. That's it. If I turn it off, you will see they will not die anymore. And of course we can set more quality settings here in the Fluid Dynamics tab. I can turn off the slipping, for example. This means that whenever a particle touches an obstacle or outside boundary, the drag, or how the particle is slipping along this obstacle, will be 0. So full drag, as you can see already here. And the last thing I will do now is show you how to use other NodeGroup presets to extend the setup now. Let's assume we want to have a second source. Well, we only have one slot here that says emission mesh. So how can we define a second one? Of course, we can always do this by using low-level nodes, and there's a tutorial already for that. Please take a look at low-level basics. So I won't go into that, but I will show you how to use NodeGroup presets to accomplish the same. Let's open up our presets, go into bodies, and now we can see here, let's just take volume mesh. Put it down here, and the volume mesh takes a Cinema 4D mesh. In that case, it has by default a sphere on it. There we go. So let's say I want this one to be my second source, right? Okay, I have it here, and the next node group I will create is particles, emitter, liquid particles. So this is another NodeGroup preset. I'll drop it all in here, and we can see how this list of operations in the pipeline viewer is growing, and we can exactly see which operations happen when, and we can of course also change this later. Anyway, let's stick to our volume mesh and our emitter liquid particles, and here I can set a volume again. If I use it, now I get my list again for all the candidates. We have flip particles and flip partostatic obstacle volumes, which we knew before belong to the liquid flip NodeGroup preset. And we have volume mesh, well, that we just created, which we want. So let's do this. There we go. Still no particles, because we still need to find a target particle group. Again, the candidate button. Always use the candidate button. You're always on the safe side. Flip particles. Well, that's what we want, right? We want more flip particles. And here we go. Once we have defined that, we got the flip particles. Let's turn this off again, so we see the particles. And for this, we can do just the same with the constraints, for example. You can also use here the noise constraint, for example. Here we go. And that's how you create another, well, liquid source. Also here we have parameters for how long the emission should take. You can give it a normal speed, just the same. It's just the same settings as in the emission settings here. Well, there we go. So you can work with NodeGroups and build up your setup much the same as we did in Effex 1.7. That's why we have added these NodeGroups, because they feel a little more intuitive to the beginner especially. This makes it easier for you to step into the Effex framework. Alright, so this should be it for the Quickstart introduction. Keep on tweaking your simulation, try the NodeGroups. If you have a question, ask in our community forums. Keep on tweaking settings, and check out all the other tutorials on our website, for example, or in the user area if you're a customer, and get into it. Well, hope you enjoyed this tutorial. Thanks for listening, and hope to see you soon again.